Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to look at the use of the method of washers of finding volumes of solid of revolution. So, let me write down the name of the method of washers. We'll see why we call it that in a second. Suppose you are trying to find the volume of a solid. And this solid is resulting from the intersection of two graphs. Let's say the first one, it's a function f of x just simply equals x. And the other one, g of x equals x cubed. Let's make it x cubed. Uh, in the first quadrant, Q1, and we are rotating about the x-axis. How do I find this volume? So first, let's draw these graphs. We are in the first quadrant, so I'll go down here, do the x-axis and y-axis. F of x is a straight line of 45 degrees, roughly that. We are only in the first quadrant, so I'm going just to draw a ray. No reason to extend the line. And this is f of x. G of x in the first quadrant would look something like that. Notice this would go down after that, but we are in the first quadrant, so we need to find the points of intersection. Again, by inspection, we know it's 0, 0, and 1, 1, right? That's the only where in the whole 2D that where x equals x cubed. You can solve x equals x cubed, so you factor out x and you get x squared minus 1. So I have three, since that's a cube, we have three solutions, x equals -1, or x equals 0, or x equals +1. But since we are in the first quadrant, they are only 0, 0, 1, 1, so we are not going to waste time writing it, but you know better than me how to find these points. Now, if I rotate around the x-axis, notice that the washer method, you'll see why we call it the washer, it's applying the disk method twice. How is that? Here is the piece, or here is the area. If this is dx, the height here would be f of x minus g of x, right? And when I rotate it, what do you think we will end up having? Notice this piece is void, right? So you will get something that looks like that. And this should be identical to that. Of course, it's not identical, but it should be. And that distance would be exactly equal to that distance. So if I look sideways, what do you see? Or what should I see? I claim that I will see the following. I will see a circle in the middle. And this thing is not good enough, I think. Oops. Oh my God. It doesn't draw perfect because the lead is short to change it. But you will get roughly something that looks like that, where this is the area and the middle is a void. So it looks like a washer, right? You know, if you are tightening a nut and you get a washer that you insert, it's going to look something like that, where the inner radius is basically, in this case, it's g of x, and the outer radius is f of x. And the thickness is dx. So when I rotate this, it's as if I'm using, oh my God, something is, sorry. You will get this piece forming a disk, and then you will get this part rotating and forming a void. So it's like you are doing exactly, that's the volume. The volume would be, if this was a solid piece, I didn't cut anything from it, the radius would be f of x. So it's pi f of x square dx, right? And then you cut from it a piece, a disk that has a height of g of x. So minus the disk, which is g of x square dx, and that's dv. That's exactly what we have. So really, we call it the method of washers, but it's the difference between two disk methods. It's the same disk, a big disk, and you cut from it a small disk. So it's not a new method, but it shows you that it reminds you that you have to subtract the void generated by rotating this piece only about the x-axis. So you factor out the pi, and you get f of x squared minus g of x squared, and you factor out the dx. A word of caution. Many students, hopefully not you, would say, it's pi times f of x. When they write it quickly, they say f of x minus g of x quantity squared dx. Absolutely wrong. Why? We are not subtracting this. This is not the radius of rotation. The radius of rotation is this whole piece minus that whole piece. So see, if I square that, I get f of x squared, okay? But then minus twice f of x g of x, which is not here, plus g of x squared, I have minus g of x squared, so it's completely wrong. Be careful. Think of it as two disks, a big disk minus a small disk, okay? In this case, we are going to say our volume is the integral from 0 to 1, right? I know the points of intersection. Whether I'm rotating about the x or the y, it's going to be from 0 to 1 because the points of intersection are 0, 0, and 1, 1. Pi is a constant. I take it out. F of x, which is x, I'm going to square it, minus g of x, which is x cubed, I'm going to square it, dx. So that becomes pi times x cubed over 3 minus x to the 7 over 7, evaluated from 0 to 1. Notice when you substitute 0, you will get 0, so there is no reason to say this minus that. There is no subtraction. You know that when you subtract 1, you get 1/3 minus 1/7. You should all know that it's 4 over 21 cubic units. Notice that if you have, this is common thing, is that if I have a numerator is the same, 1 and 1, 2 and 2, it doesn't matter. But let's take the simple case. If I have 1/2 minus 1/3, okay, the numerator is the difference between these two guys, meaning the big, or the right minus the left, the one that is subtracted minus the other, because if I say 1/3 minus 1/2, it would be -1 in the numerator, and 2 times 3 is 6, you get 1/6. So 1/3 minus 1/7, right minus left is 4, 3 times 7 is 21. And that's, you don't need to take a common factor and do it, you can do it very quickly. If it's plus, you add them up instead of subtracting, so it doesn't matter right plus left or left plus right. So 1/2 plus 1/3 2 plus 3 is 5. 2 times 3 is 6. And of course, if both are constant, so 5 halves minus 5 thirds, keep the 5 in your head, do the subtraction, and then multiply by 5. So you get 5, 6. You see that? Should be very easy. Okay. So that's basically it. You see how easy it is? We apply the method of, it's as if we found the volume of the outer disk, the whole disk, and then we found the volume of the inner disk, and we subtracted them from each other. Nothing new. Let's take this same example and rotate it about the y and see what we get. Okay. So now, do you see what will happen? First of all, I have to express my piece in terms of y because I'm going to rotate it about the y-axis. So the outer is g of x, the inner is f of x, and it would be the integral rotating about the y. The volume equals pi is a constant, so let's take it out. Integral from 0 to 1. I'm going to take g of x, g of y. Notice g of y, meaning if g of x equals x cubed, I want to find that in terms of y. So I will say x equals, in this case, the cube root of y. And for f of x equals x, we say x equals y. So I'm going to say g inverse of x minus minus f inverse of y. So I will get cube root of y minus y quantity square dy. That would give me the volume. So I'm going to say pi times the integral from 0 to 1 of y to the 2/3 minus y square dy equals pi times. You add 1 to the 2/3, you get 5/3. You divide by 5/3 is like you multiply by 3/5. So 3/5 y to the 5/3 minus 1/3 y cubed. And again, we evaluate from 0 to 1. We don't care about the 0. It's 0. So I will get pi times 3/5 minus 1/3. Here, it's not the same numerator. It's not the same denominator. So I'm going to take a common denominator of 15. 15 divided by 5 is 3, times 3 is 9. 15 divided by 3 is 5, times 1 is 5. So you get 4 pi over 15 cubic units, which is roughly 0.2666 pi. This one is slightly less than 0.2 pi. Okay, so you see that rotating it about the y will generate more volume than rotating it about the x. But in both cases, we are taking the bigger disk minus the volume of the bigger disk minus the volume of the smaller disk. And that basically is the method of washers, nothing new. It's the same method, but you apply it once for the outer region and once for the inner region, and then you subtract. I hope this was clear enough for you. If you have any questions, please let me know in the method, I was going to say in the method of comments. Okay, that's a method that you can embed in calculus and help other people, and maybe you can help me with that. But putting that aside, if you want to leave me a comment, I would be very glad to respond to you if I have time or whenever I have time. Thank you very much for watching, and hope you have a great day, and see you soon.